We're now going to look at inheriting classes in Java. I have a project set up, and just before we start, I'm just going to talk you through the structure of the project. So we have an employee class. It just represents a name and surname and start date of an employee. Now, in the real world, there'd be a lot more properties, but we just want to keep it simple for now. I have another little class which is a series of static functions just for working with dates, just to keep things easier. Okay, so one allows us to make a date based on a year, month, and a day. Another allows us to add a number of days to a date, and another one just gets this time last year. Okay, so don't need to worry too much about these. This is just sort of for the purposes of the demonstration. Okay, and then in my main class, currently I create two employees. One I set with a start date of today, and the other I set with a start date of this time last year using the date functions class. I then create a list of staff members. I add the two staff members I've created to that list, and we print out their surnames. So if we were to run this, you should see. There we go, that it runs. I'll just put this into presentation mode so everything's a little larger and easier to read. Okay, so let's say, for example, we've been running the system quite nicely, and then we come along and we discover that actually we want to be able to appoint temporary employees, so people who are going to have a contract end date. Okay, now what we could do is we could go into employee and we could add a contract end date, but for some employees that would have to be null, which is not necessarily the most helpful. Similarly, we might want the ability to extend somebody's contract, but again, that's not going to work if they're a permanent employee. So what we can do is we can say, well, actually, I want all of the functionality that belongs to employee, but I want to be able to add some additional functionality that is specific to an employee when they're a temporary employee. And that's where overriding or inheriting from the employee comes into play. We can keep all of the usefulness of our employee class. Spot a little mistake here in that our properties are not private, so we should probably fix that before we continue. We keep all the usefulness from employee class, but we can add some additional functionality to it. So it's reasonably straightforward to do it. We just create a new file, so we can say new. In this case, we'll choose a Java class. We'll give it a name, so I'm going to call it temporary employee. It's a class. And what we're going to do is we're going to say that it extends employee. Okay, so it's giving us a warning, and it's saying there's no default constructor available in com.tinyoutcode.employee. So basically, there's no way of constructing this class. If we try to create a new instance of temporary employee, because there's no constructor that doesn't have any parameters, it doesn't know how to set up the employee bit of employee. Okay, so we need to create a constructor. So we can say public, there is an option to get it to do it for us, but we can say public temporary employee. Okay, and if we look at the constructor for our employee, we can see it takes a string, it's a forename, a string, it's a surname, and a start date. So we can decide that we're going to need all of that at least for our temporary employee. So we can pop that in there, okay, and we can essentially what we want to do is we want to send this information to the employee bit of the inherited class. Okay, so like when we do new employee in other classes, we need to call the constructor. Okay, well, if we look at the employee class, if we wanted to call a method in it, the methods have all got names, but the constructor doesn't. It's just employee. So there's a keyword, a Java keyword, that allows us to access things that belong to a class that we inherit from. Okay, and the class that we inherit from is called a superclass, and the keyword is super. Okay, so if we do super and pass in brackets, we can pass in the parameters to the constructor of employee. So I can say forename, surname, and start date. Okay, so now my temporary employee has everything that my employee does. Just as an example, if I wanted to at this stage, I could go to my main class, I could create a new temporary employee, say temporary employee, give them a name, I don't know, Robert, equals new temporary employee, and Robert Jones, and we could start them today as well. Okay, and the other really useful thing about an inherited class is that it is still an employee. So a temporary employee is an employee, and that is always the case. We've got to remember that an inherited relationship means that whatever the subclass is, they still have everything that is true of the parent class or the superclass. So because a temporary employee is an employee, I have a list of employees. I can add Robert to, we've done it the wrong way around there, I can say staff members dot add, and I can add Robert to that list of employees because a temporary employee is an employee. Okay, I'm going to take that out just for a minute because we're going to do a little bit of tweaking around and I don't want this code to break. So that's all well and good, but you might think, well, what have I gained? I've just got a temporary employee that's exactly the same as an employee. And this is where it becomes really useful. We can now add the things that are unique to our temporary employee. So we can say, for example, well, we're going to have a contract end date. So we can create a property. We can say private end date, which is going to be, in fact, it's going to be a date. So I need to put the date there first. We can say private end date. We probably want to be able to set the end date when we construct the employee. And we probably also want to be able to get the end date. So we could say public date, get end date, turn end date. And we might even want to extend their contract. So we could say public void extend contract by number of days. Okay. So then we want to change the end date to a new date. So we can say like date new end date equals current end date. But actually we want a function that allows us to add days to a date. So you notice one of my functions is called add days. So if I call date functions dot add days, I could say date function dot add days. I could pass in the current end date and the number of days, and I'll get a new date out of that, which I can then store an end date. Okay. Now, the only sort of slight problem here we've got is that if we create our temporary employee as it currently stands, we never set end date. Okay, it's not set in the constructor. There's no setter for it. So that gives us a problem because the whole point of a temporary employee is that it must have an end date. Otherwise, they wouldn't be a temporary employee. So what we would do is we can modify the constructor to take a new date, end date. Okay, we leave the call to the parent class constructor, and then once that's constructed, we can say our end date here is equal to so it's this dot end date. Okay, so that gives us our temporary employee. So if we go back to our main class, if I put this in, we're going to get an error now because when we created our temporary employee before, we didn't require an end date here. Okay, so again, I might want a date that represents next year. So I can say date next year equals date functions dot want to add days to a date, so we could add to today, we could add 365 days. I know it's not perfect because it could be a leap year, and then we could say the contract ends next year. Okay, similarly I can still add Robert to my staff members because Robert is still an employee, but Robert also I can say if Robert dot get end date dot before today, then Robert has left house. Robert dot Robert still in employment. Okay, but yeah, he's still a staff member. So if I run my code, there we go. Robert's still in employment. I mean, if I change this to instead of in date functions, so next year I could say what was it? Date functions dot this time last year. Okay, I know it doesn't make sense because we'd be employing him before he finished, but we should find that Robert has left. Okay. One thing I will just mention is that when we add subclasses, instance of subclasses to a collection, okay, they obviously inside the collection they are treated as that parent type. Okay, so obviously Robert is a temporary employee and therefore we can call get end date on Robert in most places. But if we're treating Robert as an employee for the purpose of the list, so inside this loop, okay, the first two times this loop's going to go through, the employee is going to be Andrew and Graham, who aren't temporary employees. Okay, so it's not possible to say, for example, in here, employee dot get end date. Whilst obviously when we know Robert is a temporary employee, we can do Robert dot get end date. Similarly, it's also perfectly legal to create a new temporary employee, but actually just reference them as an employee. Okay, so I can do that, but I lose the ability to get the end date because it treats him just like a regular employee. Okay, so we have to think about the type that's been declared as well as the type of what it is in terms of what we're going to have access to. Okay, so I'm going to put this back to temporary employee and we will get the behavior from Robert. Okay. One other thing, it sort of doesn't, it's not a great one for this example, but sometimes we might need to call. In fact, we can do something here. So let's say, for example, that in any system where an employee's surname is printed in this HR system, if they're temporary, what we want to do is to put temporary in square brackets after their name. Okay, and the way we could do that is we could go to a temporary employee and we could override or change the behavior of the get surname method. Okay, so if I'm in my temporary employee and I start typing get surname, it's going to pop up and suggest, oh, that's a method that belongs to employee. Okay, and if I double click on it, what it's going to do is it's going to implement that method. It's going to mark it as being overridden. So this is what's called an annotation. And it's saying this is overridden. You're changing the behavior of something that exists in a parent class. Okay. And in fact, there we go. It's probably going to tell us. Indicates that a method declaration is intended to override a method declaration in a supertype. And then it says, there's error messages that can be displayed if you don't do anything other than what's already there. So what it does at the moment is it basically calls get surname from the superclass and returns it. Okay, but what we might decide is, well, we want that behavior, but we also want to append to it temp in square brackets. Okay, so now, and we don't have to write return super. We could say string name equals super dot get name, get surname, and then we could say return name plus temp. Okay, so now if we go back to our main class, you can see that we've got a list here that prints out the surname of each staff member. Well, for temporary staff members, even though in here they're being treated as an employee, for temporary staff members, it will call the method that belongs directly to that to whatever type it is. So for our temporary employee, for Robert, it's going to append temp to his name. So if we run that, we'll see that behavior happening. Okay, so we can adjust the behavior, we can override the behavior, okay, of the parent class. Okay, now you've got to remember that that in this case Robert is an employee, a temporary employee is an employee. So we don't want to sort of break or remove behavior that's still there. So, you know, when we call get surname on a staff member, we can expect to get their surname. Okay, if we don't get their surname, it's broken. So if we replaced it with just temp, we're kind of, you know, voiding the whole purpose of having the thing. But you could argue that giving the surname with an extra temp on the end, it is not breaking it, because you're still getting their surname and it still works. Okay, so that's the thing to remember. An instance of a subclass, in this case Robert, our temporary employee, is still a full employee, is an employee as far as everything that relates in the employee class goes, and we don't want to be, you know, changing it. So a good example of something that would break this rule is if we created a dog class and then we decided that, well, cat's kind of like a dog, so we'd inherit cat from dog. That falls down, because immediately you lose the bark behavior. You know, a cat can't bark, and a cat isn't a dog. Okay, so we can't override, we can't inherit from something and make something that isn't. You know, we might have a car and we might think, oh, well, a bike is just a car with two wheels, so we'll inherit bike. No, you're gonna break. It's not going to work. Okay, so you need to make sure that when you inherit from something, the thing that you're creating is the thing that you're inheriting from. Okay, and that's inheritance.